Now x tends to 0, therefore px by 2 tends to 0. I use that sin px by 2 px by 2. Actually we are forming here the standard limit form. Now limit x tends to 1 fx is equal to limit x tends to 1 of x plus 1, that is equal to 2. Next sum, the given function fx is defined like this. Then if fx be continuous, we have to find the value of p. First of all, we have to discuss the continuity of the function at the point x equal to 0, because for x not equal to 0, the function is defined like this, and for x equal to 0, value of the function is half. Therefore, it is to be understood. The approach will be like this: continuity of fx at x equal to 0. Fx will be continuous at x equal to 0 if limit x tends to 0 fx equal to f0. You see, we have to calculate the limiting value. Now limit x tends to 0 fx equal to limit x tends to 0 1 minus cos px by x sin x. Already I have mentioned, for finding the limiting value, we have to replace fx by this value, since here x is not equal to 0. Now we calculate this limiting value, that is equal to limit x tends to 0, 1 minus cos px means 2 sin square px by 2 by x into sin x, that is equal to limit x tends to 0. Now we form standard limits. How? Since there is sin x, therefore we one by sin x by x. For balancing, we must multiply at the denominator x. That means there will be x square 2 sin square px by 2. Now x tends to 0, therefore px by 2 tends to 0. I use that sin px by 2 px by 2. Actually we are forming here the standard limit form. Now p square by 4 has been taken, that is not in the original form, therefore that is to be balanced by multiplying it p square by 4. Here x is variable, therefore we can do that, and this 2 is multiplied here into note this sin x by x, limit x tends to 0, value is 1. Let me check sin square, sin px by 2, px by 2 square by 4, therefore 2 into 1 into square by 4. That is equal to square by 2. Therefore, limiting value is square by 2. Therefore, square by 2 will be equal to half. If 0 is equal to half, therefore square equal to 1, from that we get p equal to plus minus 1. Thus, if x will be continuous at x equal to 0, then the value of p will be plus minus 1. This sum is solved. Now, to solve this sum, I must mention the standard limit to be used. That was not discussed in 11, that is why I mention here. Standard limit. Limit x tends to 0, 1 plus x to the power 1 by x, that is equal to e. Limit x tends to 0, this standard limit is to be used here. I solve this. Fx will be continuous at x equal to 0 if limit x tends to 0 fx is equal to f0. Now, limit x tends to 0 fx equal to limit x tends to 0. In place of fx, we have to put this 1 plus 2x whole to the power 1 by 3x. We calculate this limit. Already I have mentioned the standard limit. Here we find limit x tends to 0, 1 plus 2x whole to the power 1 by 3x. I have substituted 2x by z. Therefore, z tends to 0 as x tends to 0. Now, I have calculated the value of 1 by 3x, that is equal to 2 by 3z. Now, after putting those values, we get limit z tends to 0, 1 plus z whole to the power 2 by 3z. Now, the standard limit is limit z tends to 0, 1 plus z whole to the power 1 by z. And I can write this 1 in this form. Therefore, value of this standard limit is e to the power 2 by 3. Therefore, value of k, I think k, value of k is better I mention that statement. Therefore, fx is continuous at x equal to 0 if 0 equal to limit x tends to 0 fx, therefore k equal to e to the power 2 by 3. This is the answer. For this sum, fx is equal to x plus 1 when x is less than equal to 1 and its value is 3 minus ax square when x greater than 1. If this function fx be continuous at x equal to 1, then what will be the value of a? This is the question. We first mention that condition. Fx will be continuous at x equal to 1 if limit x tends to 1 fx be equal to f1. Now limit x tends to 1 fx is equal to limit x tends to 1 of x plus 1, that is equal to 2. Limit where it will be left hand limit rather. Here we see x tends to x is less than equal to 1, therefore it will be left hand limit, then right hand limit, limit x tends to 1 plus 3 minus ax square, that will be equal to 3 minus a into 1, that is 3 minus a, and f1 value of the function fx when x equal to 1. Note this, x is less than equal to 1, which includes x less than 1, also x equal to 1. That is why f1 is calculated from this condition, f1 equal to 1 plus 1, that is 2. Therefore, this will be equal 3 minus a equal to 2. From that, a equal to 3 minus 2 equal to 1. Therefore, final statement is, if fx is continuous at x equal to 1, then a equal to 1.